We have discovered how dependent we have become on networking technology. So it was a bit of an improvisation here. We're going to proceed as if nothing happened. This session is going to be about how you can actually use attributes and authentication authorization in more advanced scenarios. We have 3 speakers today. Roland from Rijswijk from Surfnet will begin, followed up by Lucas if his presentation gets here on time, depending a bit on the available bandwidth. And after that, Martijn Oostdijk will continue. So I'll invite you to give a hand for Roland.
Okay. Thank you. Good afternoon, everybody. Just like everybody else, I depend on a network connection to be able to give a demo. So I'm hoping it will be up later, and otherwise I'll use my very slow GPRS link to do the demo. And we've had to improvise a bit, so I've got all presentations open on my laptop here. Let me just start my own presentation. Okay, so I'm going to be talking to you about a project that we call IRMA, or I Reveal My Attributes, which is an academic project that we're doing together with one of our universities. And it's not just with one of our universities, we are also working with TNO, that's the Netherlands Organization for Applied Scientific Research, and SIDN, they are the top-level registry for the .nl CCTLD. The IRMA project was initiated about a year ago, and we are going to be using attributes in this project. And you should all be familiar with attributes, otherwise you wouldn't be in this room, right? Who doesn't know what an attribute is? Wow, Nicole, you're cheating. So attributes are properties of a person, right? They are their full name or their date of birth or a social security number, which are all highly identifying bits of information, or they could be something less identifying, like my age. Am I over 18? Am I younger than 65? Am I a student? Did I enroll for a particular course? Those are all attributes that describe a user, and we use them in a variety of scenarios. Because in the federation community, we've been using attributes for years, right? For the last 10 to 15 years, identity federations have been ruled by attributes. And most of those rely on protocols like SAML2, and they rely on information about you as a user being released by an identifying party called the IDP to somebody who relies on that information, the service provider. And that is what we call attribute-based authentication, right? I'm telling you nothing new here. And if we look at what attribute-based authentication looks like in a more abstract way, then normally the user should be somewhere in the middle, right? It's all about the user. And if the user wants to identify himself to a relying party because he or she wants access to certain services, they first go to an issuer of attributes and ask them, can you give me some authoritative information about me that the relying party is going to trust? For instance, can you give me an authoritative response that my email address is roland@surfnet.nl? And then I get that from the issuer, and as a user, I transfer that information onto the relying party, and they check a digital signature and allow me access to certain services. And an issuer in a federation context we call an identity provider, and the relying party in a federation context is a service provider. Nothing new here. But what if we look at privacy and attributes? Privacy has been a hot topic for a number of years. We've been dealing with consent and discussing all the pros and cons of asking users whether or not they want to allow access to stuff, and discussing all the legal implications. But in federations, despite the fact that we've been introducing consent into federations, the user still has very little influence over what information is being transferred. That is because the negotiations about what information has to be released in order to authenticate is usually not between the user and the relying party, but it is rather between the relying party and the identity provider. That's because for relying parties, it's much easier to negotiate with a single identity provider than having to negotiate with all these users, but it does mean that the user has very little choice. And if you look at attributes, as I already mentioned, there are identifying attributes, such as your social security number or your name, but there are also heaps of non-identifying attributes that can serve really well if you have to have access to certain resources. Because if you want to, I don't know, go to a streaming video website where you want to watch content that is only suitable for people of a certain age, do you really need to reveal your name or your social security number, or is it enough that there is an authoritative source that says that you are over 18 and that is all the information they get about you? And this is something that we are hoping to introduce with the IRMA project. And for that, we use a technology by IBM Research that's called IDMX. And that was originally developed by Jan Kamnisch and Annelies Janskaya in the early 2000s. And it is an extremely privacy-friendly technology. Again, it is attribute-based, and they use some really advanced cryptographic techniques to ensure that users have a maximum amount of privacy while relying parties still get a highly trusted source of information about users. And another key aspect of IDMX is that it gives the user full control over their attributes. Not only does the user have to consent to all attribute releases, but they can even pick and mix and get attributes from different providers and combine them into a single identity. I'm going to go into a little bit more detail about the technology behind IRMA now. If we want to keep trust between relying parties and users, we need certain properties of the technology, right? We need what is called non-transferability. And that means if I have, as a user, if I have a set of attributes, I should be able to use them, but it should be hard or impossible to transfer them to another user, because otherwise the trust breaks down. If all a relying party gets about me is that I'm over 65 or whatever, then you can see that it's very easy if I copy that attribute to someone else and they can abuse it. We really don't want it to happen, so it should be non-transferable. Another key property that we want to achieve is what we call issuer unlinkability. And that's an interesting one, because what we want is that issuers of attributes, so the people that provide authoritative information about you as a user, are unable to trace where you use those attributes. And if you think about it, in our current identity federations, that property does not exist. Especially in mesh federations, identity providers know where you are using your identity. And you have to ask yourself whether that is really a desirable property. Does your home organization really need to know where you use your identity? Another key property that we want to achieve is what we call multi-show unlinkability. So if I go to a service provider and identify myself with certain attributes, and I come back to the same service provider, I don't want them to know that they are dealing with the same person if they don't have to know. And this is what we in Dutch call the bonus card scenario, right? If you go to a supermarket, they give you these loyalty cards, which you can use to get reductions on all sorts of goods in the supermarket. But the annoying thing is that they try to track your purchase behavior based on the number of that card. And we want to stop service providers from being able to do this based on identity information that they get to access their services. And also, we want colluding service providers. So if I've gone to service provider A and then I go to service provider B, from comparing the identity information that they got when I logged on to see that not only did I shop at Amazon, but I also purchased online content at Netflix. And then they can sort of collude to build an online profile of me, because if I read a book, then I'm likely to purchase the DVD later or watch the online video stream. Now, these properties are all realized by the IRMA technology. And as I said, they rely on novel cryptographic techniques, such as zero-knowledge proofs and blind signatures. And I'm going to try to explain one of these to you, just to give you an idea about what we're doing. And I see that while I reorganized my presentation, I messed up 2 slides, but that's all right. So I'm going to show you this one first. The key concept in IRMA are credentials. And these credentials have a certain structure. They contain a secret key, and they contain a coherent set of attributes that belong together. And I'm going to show you some examples later on. And finally, there is a digital signature on on the credential by an issuer that proves that this information is reliable. Now, if I reveal information from one of these credentials, I can selectively reveal attributes that I need. So if I have a credential that has my address in it, and for instance, the country that I live in, and it's a credential that I got from my government, then I can decide that I only want to reveal which country I live in, because I can access certain services if I'm from the Netherlands. Now, if I selectively reveal one of the attributes, I still need to prove that I have the rest of the attributes, because the digital signature is over the whole credential. And to do that, I use zero-knowledge proofs. Now, a zero-knowledge proof of knowledge, as it's called if you give the complete name, works as follows. I'm going to use a little analogy to demonstrate it to you. And what you see on the slide here, the rather abstract figure, is Alibaba's cave, which has an entrance on the left, and it has 2 tunnels that lead to a door that is in the back, and you can get there through route A and through route B. And we have 2 actors in this little game. One of the actors is Peggy, the prover. As you know, cryptographers like to give their actors little names. We usually have Alice and Bob, but in this protocol we have Peggy and Victor. And Peggy wants to prove to Victor that she knows how to open the door at the back of the cave without revealing how she does that. So they play a little game, and what Peggy does is she will enter the cave, and then she will randomly pick one of the 2 routes to go to the back of the cave. And in this case, she picks route A, goes to the back of the cave, and then waits there. And then Victor will enter the cave as well, and he will randomly select a path through which he wants Peggy to return, and he will shout that out so that she can hear it at the back of the cave. And in this case, he said, "Please return through path B." And as you can see, Peggy needs to open the door in order to be able to do that. So she opens the door, and then she returns, and Victor can observe that she returns through route number B and says, "It's okay, you know how to open the door." Now, we repeat this game a number of times, so it's a probabilistic protocol. And if we play the second time, Peggy enters the cave again, randomly selects a route, she picks route A again, and then Victor goes in and says, "Please return through path A," in this case. And as you can see, Victor can't tell how she opens the door, because she returns through the route that he asks, but she didn't actually have to open the door. So how can she really convince him that she's not faking it? Well, we play this game lots of times. And it turns out if you play this game about 20 times, then Peggy has a... Ooh. I think I got I got Lucas's presentation now, so that's great. We can show you everything. Right. So if we play this game about 20 times, then Peggy has a chance of less than 1 in 1 million to convince Victor that she knows how to open the door. And in actual fact, if we implement this for the IRMA-specific implementation, doesn't do this 20 times, it does this 2 to the power of 80 times. So even though it's a probabilistic protocol, the chance that the zero-knowledge proof is faked is negligible. So here are some examples of credentials. For instance, you can have anonymous credentials that say something about your age. So they say that you are over 12 or you're over 21 or you are over 60, so you can get a reduction in public transport in the Netherlands. And then there are identifying credentials, such as your address or your ID credential that you get from the government, which has your social security number in it. And remember, you can selectively reveal parts of these credentials, and you can even combine information from 2 credentials if you want to, for instance, prove that you are over 18 and that you are from the Netherlands. Then that means we have a very privacy-friendly wietpas, as we call it, which you can use in coffee shops to buy sort of marijuana and things like that. Until recently. Yeah, well, no, if you're from the Netherlands, you're still allowed to do that. Where's my smart card? That's interesting. I wanted to show you my smart card, and everything is really going wrong now. Because we were messing around with these laptops. And now I seem to have misplaced my demo card. Oh, yes. Thank you. Give Franz a round of applause for reminding me where I put it. So this is a picture of the smart card, and I've got one here, so I can prove that it really exists and it really works, and I will show you in a minute. This is a programmable smart card that you can put little applications on. It's called a Multos smart card, and there are two different kinds of programmable smart card. Doesn't really matter, but this is a Multos smart card. And researchers from the research group, which I'm a part of, have created an implementation of the IDMX technology that works on a smart card. And actually, they have the world's fastest IDMX implementation on a smart card. And with that, I mean that it performs reasonably well. It works. It takes about a second to prove that I have certain attributes, and that's really quick if you compare that the second fastest implementation takes about 8 seconds, which is completely unusable if you want to use it in practice. And as you can see, the only identifying information on here is my picture. There's nothing else on there. There are no secret tags on there. And I want to show you how this works. So I'm going to demonstrate an offline scenario first, and then I'm going to see if network connectivity has been restored. It has? That's wonderful. See, that's what you get if you let me do a presentation. The DNS stops working. So I'm hoping you can see this. I've got a tablet computer here. And the first demonstration I'm going to give is an offline demonstration. So that means I can do this without having network connectivity. And that is useful, for instance, if I want to use this card in a shop to prove when I purchase, when I purchase a bottle of wine, to prove that I'm over 18. So I've got an app on here, and I hope you can see this. It shows you which information is going to be revealed. It says here age 18 plus, and it says waiting for card. And this tablet has an integrated contactless smart card reader. So if I now hold my card against the device, it will read the credentials that are on there, and hopefully it shows a green tick, as it does, to prove that I have an attribute that says that I'm over 18, and it's checked the digital signature, so it shows you that it's all right. And what's also interesting is that as a user, you can see there's an implicit consent in here because it says which attributes are going to be revealed. And I'm shown this information before I hold the card against the device, right? And this is a demo application. Normally, I would need to enter my PIN code as well, which makes the consent more explicit. Interestingly, as a user, I can also check after I've authenticated, I can check the log that's on the smart card, and it will show that I revealed that I'm over 18, and it will show which relying party I revealed that information to. And we can also use this in an online scenario. So now we're going to see if the network really is back. Now I just have to reassociate with Eduroam. Give me a second. Let me turn this off. And then see, there we go. Eduroam. Yes. Okay, so I'm going to give you the decent demo, not the dodgy one. For the Dutch people in the room, you know what spuiten and slikken is. I'm not going to show you that. For those people who are interested, come up to me afterwards. You need to be over 18 to view that.
You certainly know how to capture your audience.
So I've got an Android smartphone here. I'm not going to use the tablet because this has a rear-facing camera, but it has the same applications on it as the tablet does. And in this case, I'm going to prove to the website of the New York Times that I'm over 12. And interestingly, we picked that example because there was a discussion a couple of weeks ago that the acceptable use policies of all these newspaper websites require users to be over 12. Which basically means that kids in primary schools can't do research in newspapers anymore, which is really worrying. So if you're interested in that, Google it. I'm sure you can find the article somewhere. But luckily, we can prove that we are over 12 to the New York Times using this technology. So what I'm going to do is I'm going to use the phone as a remote smart card reader. So I have an application on here that's called Card Proxy, and I'm going to say use phone. So because my laptop doesn't have a smart card reader in it. So I'm going to link the two sessions using the QR code. And now this says waiting for card. So I hold this up and it will show a green tick when it's done. And there you go. So I now use the same card in both an offline as well as an online scenario. And I've just proved to the website of the New York Times that I'm over 12 and I can now continue to the website. Now let me get back to this. And the final demo, which unfortunately I'm unable to demonstrate live because they wouldn't let me bring this device to the conference, is that we've implemented this on a point of sales terminal. So this is a normal electronic point of sales terminal that you may encounter in a restaurant. It's one of the portable sales terminals. And the company that makes these has implemented the IRMA technology on the device. And that means that I can prove to the merchant using a device that he already has that I'm over 18 in a very privacy-friendly way. We've recently started a pilot project where we have selected a group of students from a security master, so really critical students that we hope will break the technology, to do a pilot project. And they are all going to get one of these cards, and they can use them in a number of scenarios. And the staff of the institute that runs the master's program also gets these cards. And the students can use the card in a number of scenarios. They can use them online, for instance, to get software at a reduced price. They can use it to access course materials and grade their teachers, so they can safely say, this lecture really sucked, it was really bad, without having to fear for their grade once they do the exam. And we have a number of offline scenarios as well. They can get coffee at a reduced price at a number of teaching locations where we equip the tills with one of these devices, so the cashier can use that to check whether they have certain attributes. And they can print for free at certain teaching locations, because normally students in the Netherlands pay to print documents. And these scenarios were designed to entice students to actually use the card so that we can learn how it performs in real life. During the project, we've held a number of public meetings, and there's been a big interest in this technology. Both businesses as well as government have shown an interest, and actually the Dutch Ministry of Internal Affairs has funded some of the work because they are looking into the possibility of using this kind of technology on electronic identity cards. Now, we are always looking for parties who are willing to collaborate. So if you really like this technology, come up to me afterwards and let me know. As long as you're a non-profit, well, I assume you all are, right? You are our NREN friends. And your focus is on privacy and security, please come up to me and tell me how you would like to collaborate. We're looking for people who are willing to develop software or willing to integrate support for this technology in their software. It doesn't have to be production quality, but just so we can try it in different scenarios. We are always looking for hardware, so if you have an NFC-capable device and want to give it a try to see if it works on your device, come up to me as well. And we're looking for use cases for this kind of technology, and I'm sure there are hundreds of use cases. But for our pilot, we're looking for new use cases. Now, as I mentioned in the beginning, it's an academic project, and there is still a lot of work to do. The smart card implementation is working, we have working terminal software, etc. But one of the biggest problems we have is revocation. The drawback of having anonymous credentials is that they're really hard to revoke. Or rather, they're really hard to revoke in a privacy-preserving way. Because we could easily put a card serial number on this thing, and then we would know which card we're dealing with, and if it's revoked, we can simply revoke it. But that would take away all the privacy-friendly features that we had, like issuer unlinkability and multi-show unlinkability, because it makes the card traceable. So that's a very active area of research, and we are looking into several possible ways of solving this. We're looking at really, really advanced cryptographic techniques, but we're also looking at simpler solutions. Another thing that we want to do is see if we can equip a federation IDP with support for this technology and see if we can use this in an identity federation. And finally, we want to look into user interaction, because as you can see during the demo, the device that shows you which attributes are going to be revealed isn't necessarily trusted. So how can I, as a user, be sure that the information that is shown to me is what is being revealed? Because although I can check it afterwards, then the damage has been done because the information has been revealed. So I really want to have more assurance that the information that is being displayed is what is actually being revealed. I would like to, I know, I would like to conclude my talk by saying that what I've shown you is that authentication does not require identification. I can authenticate somewhere and show that I have the attributes I need to access a service without revealing who I am. And that is very useful in a number of scenarios. And what's also interesting that outside of federations, attributes have the future. As you can see, you can use this offline. I can use this in public transport. I can use it in a shop. So attributes are the future. We already knew this, of course, but it's good to see that outside of federations, they are also being used. And finally, I'm just going to repeat this. The technology is promising. We've got a really good implementation, but it is still far from being something that you can put on a passport or on an electronic identity card. And we are collaborating with the Dutch government, for instance, to see if we can take it to that next level. And with that, I conclude my talk. Thank you very much.
We have some time for questions. So, there, Reese.
Could you pass?
Hello. Oh, blimey. Reese Smith, Janet. Have you come across a company called Touch2ID in the UK?
Okay.
That was a question. Have you?
No, I haven't heard of them. No.
You might want to have a look at what they've done.
Okay.
Similar, but slightly different in this interesting area. So they've been working with like the government and the post office in the UK.
Okay.
Trialing a zero knowledge proof based identity stuff like you, except they're using an NFC sticker, not a smart card.
Okay.
And actual specific hardware to read it, where you use your fingerprint to authenticate yourself, but in an anonymous way, and you just get a yes or a no.
Okay.
And then they're using it for like pubs and clubs to prove over 18 and things like that.
That's interesting.
So
it sounds different from what we're doing because the processing here is actually done on the smart card, and you can't do that on an NFC sticker. But it'd be interesting to look into
so they have specialist hardware to do it, I think.
Okay.
Yeah.
Thanks.
But yeah, no, have a look.
Okay. Any other questions? Yeah.
I'll start in the back, okay?
How do you update the information on that chip?
Users can self-issue new credentials on the chip. So if they, every card that we issue now has a base credential on it that they can use to authenticate to an issuer to get extra attributes. So every credential on here has a limited validity. You need to update it every once in a while. And normally you would use, while it's still valid, you would use the existing attribute. But for instance, I have a credential on here that proves that I'm a PhD student. And I obtained that credential after the card was issued to me. So I could go to an issuer and identify myself with the base credential that is on here. And then that is enough information for them to know who I am. And they can then say, okay, we have this person in our database. They are a PhD student, so we can now issue a student credential to them. So I can add credentials at a later time. Does that answer your question?
Yeah.
Okay.
Okay, last question over here.
I lost you somewhere in your explanation where how you apply the probability inside this.
Okay. So
Can you try and enlighten me on that?
Let me go back.
Yeah, this part I got. It's the
Yeah,
next slide you lost.
No, the probability is gonna. Yeah, it's animated. So you have to play the game a number of times, because if she randomly picks a path, right, and he randomly calls a path, and that means that only some of the time will she have to open the door to be able to return. So that means if you don't play the game often enough, she has a chance of convincing him that she knows how to open the door despite the fact that she's never opened it. And that means you have to repeat the game a number of times. And if she truly randomly picks one of the two, and if he truly randomly picks one of the two, and those guarantees you can build into the protocol, then if you play the game 20 times, the probability that she can convince him that she knows how to open the door without actually being able to is less than 1 in a million, because it is very probable that she will have entered through one path and will have been asked to exit through the other one. Okay, is that clear?
Yeah, that part's clear. But how did you apply that to this car?
Oh, I can send you a link to a paper. That would take too much time to explain. Okay, thank you very much.
Thank you very much.
Do you want to use your own laptop?
As Lucas's laptop has rebooted as well, I think you want to use your own, right? Yeah. So then I will simply fill the time by telling who your next speaker is going to be. Lucas Hemley works for Switch. He has done a lot of stuff for their identity, Swiss Identity Federation. Several of the renowned documents and the documentation of this federation is by his hand. He has done work in collaborative platforms and has now picked up mobile devices, and he will explain to us how we can use federation technology and attributes and get them to mobile devices.
Thank you very much for the introduction. I think you got it pretty right.
Oh, sorry.
To start this presentation, I would like to ask a question. So, who of you owns a smartphone that allows you to install apps? Okay, that's pretty much everybody who was not too lazy to raise his hand. I guess if I ask the same question in a room full of students, the situation would have been the same. So nowadays, almost every student seems to have an iPhone or an Android phone that allows to install apps, and so it's no surprise that the universities started to think, or have already started to offer apps themselves. So this is a hot topic at the universities, and some of these apps do a bit more than just displaying the content of their web pages in a different format. Some of these apps show sensitive content, and therefore it's often the case that some authentication is needed to access the app to see the sensitive content. Now, if you create an app only for one single university, authentication is not so much of an issue, because you could, for example, use the university's LDAP server to authenticate users and problem solved. However, if there are apps that need authentication, and if these apps are used by users from multiple different organizations, the problem becomes a bit more difficult. And then it's obvious that AI, so a SAML-based authentication system like Switch AI or other federations, could be used to solve this problem, but it's not that easy. And since these apps seem to be a hot topic for the universities, we started thinking about possible solutions. Now, before we started to look at these solutions, we created some prerequisites. On one hand, we didn't want to find solutions where users of only one university would be authenticated, because that's boring. On the other hand, we wanted to present or create a solution that works for our environment, so a full mesh shibboleth-based federation like Switch AI. So the following content is probably not that much relevant to hub and spoke federation, because for them it's probably easier. We also didn't have a look at Moonshot or OpenID Connect, because that's not really deployed yet, so not usable. And this also includes the SAML ECP profile, because although it's pretty much specified, it's not really deployed yet. I guess you know the problem. So in the end, we wanted a solution that works today. That was important. Now, when it comes to the app, we also had some requirements because there are already solutions that make use of AI by emulating a web browser. So it's mostly solutions that work similar like the Slix client that implements a full-fledged web browser with cookie support, refresh, JavaScript, whatever. So we didn't want that. Then, of course, we also wanted to prevent that users have to store their credentials in the app itself. That's a bit problematic because apps sometimes can steal other apps' data. Then it also would prevent commercial companies offering apps to the university users, because you probably don't want these commercial companies getting the user credentials that were issued by the university. Of course, the users themselves are also very important, so we should make sure that the app is as user-friendly as possible, which means that if you start the app today, you should be asked for the credentials, in the best case, only once, certainly not every time you start the app. Last but not least, we want up-to-date user data within the app, which also excludes any approaches that cache the user attributes. Now, let's have a look at the ingredients for the solution that we found. This is on one hand the SAML attribute query that those of you already know that have mostly shibboleth IDPs in your federation, because the SAML attribute query was the default way to get attributes, at least for shibboleth 1.3 and SAML 1. Now, how does this work? Well, the service provider opens a backchannel request or backchannel connection to the identity provider's attribute authority and makes a SAML attribute request in order to get a user's set of attributes. The user is identified usually by a transient or a persistent name identifier that at some point was issued to the service provider. The good thing in our case is that Switch AI consists almost only of shibboleth. So with one exception, all IDPs use shibboleth, and about 98% of all service providers use shibboleth as well, which makes it a bit easier for us to use the attribute query as part of our solution. Now I've talked about the name identifiers. Since shibboleth 2, there was another name identifier added, I think even as a default identifier, and this was this persistent identifier. You might know it as eduperson targeted ID. It's not exactly the same, but in the end, the value that is released to a service provider looks the same for both. This persistent identifier has some interesting characteristics. On one hand, it's a long-term identifier, so it doesn't change very often. It's opaque, so you cannot see who is behind it. It's targeted, which means it's different for the same user if that user accesses service A or B, which is very convenient, and which also results in the fact that a service provider can only know a user's persistent identifier if that user has at least once accessed that service provider. Now, using that persistent ID and the attribute query, you can do handy maintenance operations like provisioning and deprovisioning, account data updating, and you can solve the problem with the apps. Because what you now can do in the end is create a solution like here. So we have on the left side a standard shibboleth identity provider that can issue attributes about users. On the right side, we have a sample uni app, as we call it here, that wants to know a user's attributes. In between, we have a software that we call mobile proxy, and what this software does will be explained in the next few slides, but essentially the way it works is that the identity provider releases attributes to the mobile proxy based on a persistent ID that is used by the mobile proxy to make queries. These attributes then are forwarded to the uni app. This app also, of course, can query other app-specific service data. On the left-hand side, the green part is SAML. On the right-hand side, it's basically OAuth, REST, and JSON. So that's used for the communication between the app and the mobile proxy. Now, the steps for this to work are described here. So the user has to authenticate at the mobile proxy once with the web browser. So that's one of the limitations. So we couldn't completely get rid of the web browser, but authenticating once is feasible. So that's not so much of an issue, I guess. Then the mobile proxy gets the user's persistent ID via the shibboleth service provider. This persistent ID is stored in a database that basically is a mapping between the persistent ID and an OAuth access token. This OAuth access token is, of course, generated the first time the user authenticates with AI at the mobile proxy, and that OAuth token then is also given to the app, which then can use it for subsequent requests to the mobile proxy to get the user's attributes. So for the user, it looks like this. He has his smartphone, he has his apps. So he starts his app that was provided to him for e-learning purposes or for other things that are related with his studies. Then the first time he starts the app, he has to decide how he wants to authenticate. Usually he probably is using the mobile browser directly on the device itself. So if he clicks on that button, the mobile browser opens. He's directly redirected to a discovery service where he chooses his home organization. And then in the following, he's redirected from the discovery service to the login page of his home organization. He authenticates there. And after authentication happens something interesting, because he's redirected back to the mobile proxy or the protected page on the mobile proxy that now has the user's persistent identifier or radio person targeted ID. And this page then makes a redirect via JavaScript to a custom URL scheme URL that looks about like this. This custom URL scheme will again open the app that the user initially started, and it will also provide the app with the OAuth access token. Now we are back again in the app, and the app then of course can make a query to get the user's attributes. Now for the second and third and the following times the user starts up the app of course already has the OAuth access token and can therefore make a query to the mobile proxy using that OAuth token, and the mobile proxy again makes an attribute query to the SAML identity provider, gets the user's attributes, returns it back to the app. So problem solved. Of course, the app also can make queries to other servers that, like in this example, provides data like a timetable for the student or his grades or whatever. Now, what we have been thinking about as well is it a good thing to use an in-app browser? Or is it better to use the mobile browser on the mobile device? Or is it also okay to use a desktop browser? So the user uses computer's browser to authenticate the first time. And we found, well, the in-app browser is probably not ideal because then you lose the ability that the single sign-on session could be used that the user probably already has. And the same is true for saved passwords and usernames. That's lost as well, I guess, if you use an in-app browser. Therefore, we focused on the mobile browser, and we also allow users to use their desktop browser because we also wanted to support other authentication methods than username password. For example, at Switch, we also support X509 login. That is a bit complicated to configure on the mobile browser. Here again, the data flow. If we start here at the left at the IDP releases the persistent identifier to the service provider that protects the mobile proxy. the mobile proxy creates a mapping between the persistent identifier and an OAuth access token. And this then allows to fetch the SAML attributes via a SAML attribute query from the identity provider. And these attributes then are passed on by the mobile proxy to the app via a JSON XML OAuth protected interface. We also have to talk about logout, not single logout this time, but logout from the app or revocation, because that OAuth token, of course, is used at multiple places. On one hand, it's used for the authentication between the app and the mobile proxy. It's used to get the user's attribute via the mobile proxy, and it could also be used to query a third app-specific server, for example, to get timetable data. Now that token, therefore, is quite important, and it's necessary to ensure that it can be revoked. It can be revoked either because it expires automatically, so each app can set a default length for the tokens. So it could well be that the token expires after 100 days or a few years. But the user, of course, also can log out from the app and revoke the token this way. And a third way to revoke the token is via an administration interface on the mobile proxy itself. Here we see a little screenshot. So the user just can use his regular AEI account to log in on that interface. He sees all the devices that were registered for a specific app. Then he can click on revoke. It would also be possible to change the expiration date for the user, but we haven't implemented this yet so far. Now you're certainly interested to see this in action, so I hope the movie that I embedded in this presentation is going to run smoothly, unlike my laptop before. So what you see here is first the app start, the initial authentication via AI. So the user, in this case, chose to use the mobile browser to authenticate in the app. Now, the mobile browser opened. You see the discovery service, where the user chooses his home organization and authenticates there. In this case, he chooses our demo home organization, which unfortunately doesn't have a mobile-optimized login screen. But
we can't see that anyway. So.
Yeah. Now we authenticated using the safe password on the device. Now the app got the OAuth token, makes a query to the mobile proxy. The mobile proxy makes a query to the IDP, which returns the attributes. And here we go. At the same time, another query was made to the timetable resource server, and that data is also displayed. By the way, William Tell is a famous Swiss national hero, so you might have heard about that guy. There's even a movie coming out, I guess. And now what we see is the alternative login that could be used, for example, if users have to be authenticated with the X509 certificate. That alternative login asks the user to enter a URL in his computer's web browser. So he doesn't use the mobile web browser, but types in a URL on his laptop, for example. He authenticates, for example, via X509. Then he's asked to give this device a name. And now he gets the authorization code in letters or as a QR code. So he enters that. And of course, this allows then the app to get that OAuth access token, which again allows it to get the user's attributes. Yeah. Now, the logout is pretty simple. Just click on logout, which will delete the access token in the app itself and on the server. Now, speaking about the technical requirements and disadvantages. Now, as mentioned, the persistent ID is quite central in this approach, and some federations support the persistent ID, but not the one that is implemented by the so-called stored ID, where the persistent identifier is generated randomly and then stored in a database close to the identity provider. So it must be the case that identity providers support the stored ID. And for Switch AI, that's fortunately the case for every IDP. I think also for DFN AI and other full mesh federations, this is also the case, but I don't know for every federation whether this is really supported. Then to protect the mobile proxy, we used Shibboleth 2.5. The reason for that is that Shibboleth 2.5 cannot make attribute queries by itself just like that, but you need an attribute query extension that our colleagues from Japan, from the Gakunin Federation, have written. They did a very, very good job. So it's an excellent plugin that allows you to make attribute queries by accessing a URL on the Shibboleth service provider. So we use that as well. And currently, that sample app that we created is only available for Android, but we are thinking about providing the same for iOS. The advantages of this approach are the app never gets the user's AI credential, so that was a requirement. It can be deployed immediately without any changes, so we don't have to ask IDP admins to change their configuration and do this and that. It works out of the box. And the mobile proxy can also serve multiple apps. So in this example, we used just one app, but it would also be possible to configure additional apps, of course. The future plans are displayed on this slide. Switch currently is thinking about offering the mobile proxy as a service, because our university people have mentioned that, well, this is a hot topic for them and they would like to do work in this area. The code that we have right now available has not yet quite production quality, but I think it's in a good shape, so there probably is not much needed to bring it to the production quality level. It's already available as open source, so there are 3 components. On one hand, there's a sample uni app that's just awaiting to be customized. Then there is the mobile proxy, which is implemented in PHP, and there is the resource server that basically just returns back some default timetable information, but it also is OAuth enabled and therefore should be easy to adapt. More information can be found on the web page. There you also find that screencast, for example, and the subversion checkout information and additional information that could be useful if you're interested. Now last, some credits. Most of the work was done by a colleague of mine. It's a young colleague, but a very skilled one. It's Daniel Latzer. So he did most of the coding work. Then, as mentioned, we also were relying on work of the Gakunin Federation. So we appreciated that very much that they gave us the plugin for testing purposes. As I've heard from Takeshi, the plugin should be public at some point. So this URL might not work yet, but it should in the near future, I guess. Similar approaches that are worth mentioning are, for example, the work of University of Malaga. They have also created an app that probably works not quite exactly this way, but if you're interested, you could ask Vittoriano. He's happy to give you more information about that. And there is also an interesting paper where they used a similar approach to do SSH login via AI. And the information for that is also on that slide. And with that, I finish my presentation and await your questions.
Well, thank you, Lucas. Are there any questions? Yes, in the back of the room.
Hello, Alex Stewart, UK Federation. I'm wondering, because we don't have many IDPs that support persistent ID, do you in... Pardon? That's true. Of the shibboleth SPs within the UK Federation, not many support persistent ID. So I'm wondering whether Switch AAI actually recommends this to new IDPs joining your federation.
Yes, we do. So we have put in a lot of effort into writing good deployment guides for IDPs, and as part of this deployment guide that we offer, the IDP admins also install a MySQL database and configure the persistent ID. And well, it's not so much of an issue for them because we provide step-by-step the instructions, and so almost all of them manage to do this. And we did this from the start when we introduced Shibboleth 2 and SAML 2, so all of them support it. And well, that's good for us, I guess.
Any other questions?
Well, I guess Peter is not here, otherwise he would ask a question. Ah, he is.
Busy, sorry.
Well then.
Okay, thank you again, Lucas.
Thanks.
The next presenter is Martijn.
Thank you.
Thanks.
So yes, this is actually joint work with colleagues at Nové and SurfNet. Okay, let's start. So this is me, this is Nové. If you're interested in this, you can read it in the slides as I've uploaded them to the site. What I want to explain here and what my key takeaway message is if you're introducing multi-factor authentication, it's not just giving users an extra token. You're doing this because you want to have more identity assurance. That's my key message. Okay, so it's not just about the tokens, it's also about the processes. So I'm going to talk about multi-factor, about architecture and standards. How do you do this in a federation? And also about processes. Okay. So why would you want to add multi-factor authentication? Well, the obvious reason is because username passwords are weak. Okay, users forget them. Users use the same password for multiple sites. Websites or service providers get hacked. Password databases get leaked. So there are many reasons. This is a good reason, and in fact, there are many reasons like this one. But what I want to argue is, and I think that's a very good reason, right? You want to allow users to protect themselves from their own stupidity and also from stupid IDPs that get hacked. But I think the second reason is this is an enabler for higher trust services. If we're going to do business with service providers that and we're demanding things from these service providers, we're saying you should really get your security in order. I think these service providers are also entitled to know how well a user was authenticated. So we want to provide service providers with information about the authentication process and about the strength of authentication. And if you look at it in that light, it's also important that the user has been identified before you gave them the authentication token, so that the IDP really knows who this user is. So I think the second reason is much more interesting than just allowing users to protect themselves. I'll call the first reason the Google use case, as Google has introduced two-step authentication or multi-factor authentication. But Google doesn't, do identity assurance. They don't know the user any better than a user that only has username password. So that's helping users to protect themselves. What we want to do is really get to know the users better and being able, as an identity operator, to signal this information to service providers so that the service provider can rest assured that this user has been identified properly. Okay. So identity assurance and authentication assurance. Identity assurance is about physically meeting the user, checking their passport, knowing that this user actually exists and who this person is. And authentication assurance is making sure that they have a strong second factor authentication token. Talking about authentication tokens, has anyone seen this on the All Things D conference late last week? Google has introduced pills, authentication pills, which you swallow. They react with your stomach acids, and then you yourself become an authentication token. This would be the ideal token in my, the user is really, really strongly bound to the authentication token, and that's an important. You actually, you become an electric conductor of this chip, which is inside your stomach, and you can use that using your smartphone. Google is not going to be force-feeding these pills on users. Okay, so what we did was we talked to a number of organizations, a number of IDPs in the Surf Connect Federation, some different IDPs, and we asked them, are you planning to introduce multi-factor authentication? What would be your use case? And we got some really different answers, although the use cases were sort of similar. These were all internal systems, student information systems, where the teacher or the educator needed to enter student grades, and the students should not be able to enter grades, but also other privacy-sensitive data that an institute typically has. So most of them hadn't thought about face-to-face registration of users. They were mostly looking at the authentication token side of the of identity assurance. But when asked about it, they could identify that either the human resources department or the IT department could be made responsible for that part of the process. There was one institute that said, well, they thought about it and they didn't need registration, so they were just after the Google use case. Let's say, and for some institutes, second factor was not yet an issue they were considering. So different answers there. So SurfNet asked us to design a service for this to help these institutes to introduce second factor authentication and also the registration process, and to look at what standards were available for that, what the architecture should look like, and these are the requirements that are here. That it should integrate well with the federation. It should allow a variety of multi-factor solutions. We should have strict processes for registration. As much as possible, the user should be able to do most of the process using self-registration, and the administrator should have a portal also to facilitate this. And logging is important as always. So we identified some different roles here. So there's this registration authority at the IDP that is responsible for identity proofing and vetting, and also for credentialing. So the registration authority should be able to, for an individual, for a user, to be able to identify that person, to make sure that the person's passport matches with what's known about this person in the IDP's database. And it should also witness that this user has been given a second factor token and that all of this matches. So let's have a look at the architecture. And there are two questions that we were specifically answering here. Where would you locate this such a service architecturally within the Surf Connect Federation, which is a hub and spoke federation? And how do you signal the acquired level of assurance to the service provider? So where would you place this? Where would you locate this in the hub and spoke federation? Well, of course, I mean, if hub and spoke is your hammer, then you will see such a service as a nail here. So in sequence, of course, with the existing hub, where on the side of the service provider, so that if a service provider, if a user goes to one of these service providers at the bottom there, the authentication request will first pass this service, where it can be split up in two parts. The first factor will just be asked will be sent to the regular IDP, and the second factor will be sent to an external service provider that provides the second factor authentication token. So a sign-in flow would look something like this. Number one there, the user wants access to the service provider. The authentication request gets sent to this new service, which we dubbed SurfSure. I'm not sure whether this is an official SurfNet name at this point. Probably not. Surely not. The authentication request is first sent to the first factor IDP, which is the traditional username password-based IDP that was already there. The IDP will answer whether the first factor was successfully authenticated, also including some attributes there. And only if the first factor succeeded, a request for a second factor, which may be a proprietary request, it depends on sort of this cloud-based authentication token provider here, will also answer whether the second factor was successfully authenticated. And then, SurfSure can add these two up and come to a conclusion about whether the multi-factor authentication succeeded in total. Now, as you can see, there's a requested authentication context and an authentication context there. These are SAML SAML sort of elements. They're not attributes. As early as 2006, when SAML 2 was introduced, this has been part of the specification for all this time already. Let me say something about authentication context here. This is the schema that that this part looks like. Let me try to give you a sort of feeling about how big this is. Basically, what they're saying here is, if you look at the initial branching here, there are two parts. Up there's authentication method, which you should read as token. And below there's identity, which you should read as identity vetting or identity proofing. So that part is okay, except that they made an enumeration of all possible authentication methods that were known at the time in 2006. And even zero proof of knowledge is among them. So this is actually pretty good. Except the problem is, if you send an authentication context containing all of this information, exactly what token you used, what the identity proofing method was, the service providers will need to interpret this, and so there's too much information here. If you use an authentication context in this form, you will need to. Well, I think a simpler solution is needed here. And many people have come to this conclusion, and the simple solution is levels of assurance, of course. So there are 4 levels of assurance in most frameworks for this. And basically, you're just saying, okay, we're just giving a number which includes both the registration process and the strength of the authentication token. And level of assurance number 1 means we have little or no confidence in both the registration process and the token. And level number 2 means we have some confidence. And whatever that means, it differs between different standards, actually. And you get to such a single level by sort of taking the minimum of both the registration process level and the authentication token level. And we're not even sending this as a pair of numbers to the service provider, we're just sending one single number. It couldn't be simpler to interpret. Okay, so there's the original authentication context. There are context classes, which is in addition to that. There are levels of assurance, and these have been standardized in an RFC. You could also just, ignore all of that standardization work and just send an attribute. And I think there's also some standardization still going on there. So there are some different options here, and a well-known Dutch citizen-to-government framework uses authentication context classes. But they're really just using levels of assurance. They're just calling them slightly different there. OpenID Connect, which is not SAML-based, of course, is adopting the RFC way of signaling levels of assurance information. So there are some different options here. Okay, that much about the signaling or the architecture. So what about the registration process? So how should users be giving their second factor, and what information should be gathered at that point? And well, who should play the role of registration authority? What we want to do at registration time is to bind the first factor, your username password, to one of these tokens: SMS, one-time password, ticker, YubiKey. The server should be open in that respect. You know, it should be agnostic to what authentication tokens are available, or at least the federation operator should be able to add new authentication tokens if you can determine a good level of assurance for that token, of course. So it's about binding the original IDP authentication credentials to a new credential. Okay. So what can go wrong there? Well, of course, the service could be hacked. That's number 2 here. But impersonation is of course the big issue here. In order to deal with that, the registration authority should really know that this person that is there is an actual person. So we've recommended for this service that the registration authority should check a photo ID. So the person should bring their passport, and the registration authority should be an expert identity document verification authority, and check whether that passport is authentic, whether the person matches the photo in the passport. Also, the registration authority should check that the name in the passport actually conforms to the attributes as given by the IDP. Okay, so you can't send a friend to collect your authentication token. It should be you that gets this authentication token. And the registration authority should make sure that the applicant has possession of this authentication token. So it should actually, what you really should do is for both test the first authentication token of the username password and the authentication token. So the user should on the spot log into a service with both factors. Now you can do part of that. You can do in self-service, and let me just show you what the what this looks like in a number of mockups. So here's a demo. I hope this works. Yep. It's okay. So here's somebody on the day before they get to collect their authentication token. They're very excited about it. And what they're asked to do is to first log in using their first factor authentication. So they're still at home. Tomorrow they'll collect their authentication token, and they're going to prove that they have possession of the username password. So they just log in for this, and this is fine. So which one do we want? I guess YubiKey, or should we take ticker? YubiKey. Okay. So I'll start the authentication process. So I need to insert my YubiKey. So over here, I press the button. The YubiKey enters a password. Does that everybody know this authentication token called YubiKey? It's just a keyboard that you with one single button that will type the one-time password for you. We continue with this one, and it's saying my YubiKey will be added to the account that we just signed into using username password. Now we need to confirm this, that we actually did this. So an email will be sent to the user's email address as known by the IDP, so that if somebody else is doing this, you will get a notice of this. Then again, if somebody else is doing this, they already passed first factor authentication, so they already have your username password, and they can probably access your email as well. Anyway, we succeeded in this, and we get a registration code. We're going to use this registration code tomorrow when we go to the registration authority in person, and they will ask for this, actually. So the status of this second factor is still pending. It's not been completely added to my account yet, but it's at least we selected YubiKey and we proved that we were able to sign in using the first factor. Okay. So that's one. Now, the day after, we go to the registration authority, and the registration authority also has a console, and they need to sign in as well. In fact, this is Mr. Janssen. They also have a YubiKey, and of course, the registration authority should, sign in using second-factor authentication, right? If they're allowed to give other people two-factor authentication, so they should at least. I mean, it's a very sensitive service. And you need two-step verification for that. They see that this user that has come to their door actually has a pending request here. So they click that, and now they're going to ask the other person to sign in using the second-factor authentication. Sorry, they're asking them to enter the code that they got yesterday evening, so that they can be sure that the first factor authentication that they did in self-service actually succeeded. They check the passport of the person, and they check that this is an authentic passport, that the person actually looks like the photo in the passport, that the name of the person actually corresponds to what the IDP is giving in information. And they're asking the user to use their YubiKey on the spot using the computer of the registration authority. If all this has succeeded, the registration authority can approve the request. And only at this time are we sure that this user was actually that user, according to the government, of course, and also according to the first factor IDP. And that he is able to control his second factor authentication token. So only at this point are we sure that we made the link. Was there a question?
If the user has the wrong
YubiKey? They'll have to go back home and try again.
Will that show anything?
Sure. Well, so in this, you notice that this is not a real application, of course. So this is just a happy flow, not the. So these are the details that SurfNet is now considering, I guess. Yeah, good question. Okay, let me continue. So that's a good question. Another question is, what happens if the token gets compromised or lost or stolen? So somebody noticed this either the user himself. In the case of a token that is on a mobile device, probably the user will notice very quickly if you lose your mobile device. If it's a YubiKey, maybe you don't use it that often and it takes some time. Maybe the registration authority is informed via some detection system. I mean, you could combine this with risk-based authentication and see whether a user is coming from a very strange place. We've decided to just make it as easy as possible for ourselves and just give this user a new token. We just revoke the token and they'll just not be able to use two-factor authentication at this point. They'll just have to go through the whole process again. Okay, I don't know how I'm doing in time, so still plenty of time. Yes. So let me just present the conclusions, and then there's some time for questions. So why would you need a multi-factor authentication? I think many people are looking at it at this point, and one of the reasons for SurfNet to look at it at this point was that some of our IDPs are already starting to, look whether they should do this, and then of course they're opting for the primary use case, the Google use case. Okay, so they just want to give tokens to all of their education staff so that they can enter student grades safely. And I think that would be a missed opportunity to not combine this with a better process for identity assurance. So it's. I mean, the role of the federation operator here is to, there are different use cases. All of them are a bit. I mean, this is expensive, of course. Identity assurance, having users come to a registration authority in person, checking their passports, That's very expensive, but if you combine all these use cases, then you get some additional benefit from this. So it's important to do this at this point before everybody already has an authentication token and they're using all different systems, signaling different levels of assurance that mean different things to different people, to each other. We don't want that. I mean, it's important to have this standardized federation-wide. Primary use case seems to be student information systems at this point. So, but there are more use cases on the horizon where service providers are dealing with privacy-sensitive data, especially within collaborations, in research collaborations. And I've already mentioned this last point here. So architecture-wise, yes, it makes sense, especially in a hub-and-spoke federation, to implement this as a transparent proxy near the service provider-bound border of the federation hub, obviously. But I think in a mesh federation, this would work as well. So what would be the best way to signal the level of assurance to the service provider? Well, we think that maybe we should start with just 2 different levels of assurance. Level of assurance 1, where we just have traditional user password, but maybe we know the user better, so the registration process can be maybe level of assurance 3. But if you combine it with username password, you get the minimum level, which is only level 1. And level number 2, where you use an authentication token such as YubiKey or Ticker or an SMS-based one-time password solution. Again, combined with a level of assurance number 3, identity assurance registration process. You can use the levels in the new ISO standard, which are based on STORC and NIST levels. So it's good to see that this has been standardized by ISO. Or custom federation levels, but then make sure at least that they're registered using this RFC registry. Okay, so architecture is actually not the hardest part. The hardest part is the registration process, and so we think it's a neat trick. This digit or this registration code. This allows you to make it easy for users to do most of the process themselves the night before you go to the registration authority. We think it's important to check both the first factor and the second factor to really show to the registration authority that you control both credentials, both authentication solutions. And it's important to do face-to-face.
That's the session chair.
Yeah. So it's important to do face-to-face registration, to in-person registration, so based on a government-issued photo ID, and also based on federation attributes. Okay, so the registration authority should make sure that this matches, that the attributes provided by the IDP and the attributes provided by your passport match, and that you yourself match biometrically with your passport photo. And the registration authority should check that the second factor is controlled by this by the user. Okay, so we see some IDPs that still think that the Google use case alone would be enough to introduce multi-factor authentication. I think this is still an issue that we're looking at. The message that we're giving is identity assurance is more important than the token itself. So next steps, maybe somebody from SurfNet should say something about it, because I think at least this production in Q4 2013 is a bit ambitious. Yeah, right, Peter?
Wait for the mic. Yeah.
But at least they're piloting at this point based on the design that I just presented. And they're working on a proof of concept with partners.
Yes, before the summer season, holiday season, we will be meeting with our institutions and selecting institutions that want to do a pilot with us. And we're talking to other partners, authentication providing partners, to do pilots, especially regarding the registration process and how set that up. Q4 production, I don't expect that to be feasible. So that will be next year, hopefully early next year. But that depends on how it will go in pilot.
Yeah.
But we certainly want to be piloting the next half of this year.
Thanks. So in the meantime, I think open issues are, how should service providers select, which level of assurance they require for which services? Okay, it's easy for me to say, okay, this is privacy sensitive data, so you should at least ask for level of assurance number 4. But that it's expensive to reach level number 4, of course. So there should be a balance between how easy do you make it for users, and what the risk is if you make a mistake in identifying the wrong person and allowing them access to a service. So making sort of best practices recommendation for this is I think of interest. And 1 second. I think the second thing is, if authentication providers, authentication factor providers come with their new solution, maybe based on context or risk-based, or things that don't look like a YubiKey or SMS one-time password. Somebody needs to make a judgment about what does this provide in terms of authentication strength, and the same holds for registration processes. Yeah, question.
So what requirements does this put on the Federation Hub if you're lucky enough to have a hub and spoke and go to level of assurance 3 or even 4? Then I'm sure that the requirements on the hub there will also be visible or noticeable.
Let me see. Well, I think the requirements are mostly isolated to this external service here, because it depends a bit on the details. If this service actually signs the authentication assertion, including the level of assurance that has been reached, that also means that the Serve Connect Hub itself should make really sure that this part of the assertion makes the transition from IDP or to. Does it? Let me think. No, it's okay. No, I think. So this service here is talking directly to the second factor authentication provider, and only when it gets the 2 results, it will sign the assertion, or actually create the assertion that the user has been authenticated at a certain level. So it's isolated to this part. We don't need to, put the whole of SurfNet in a bunker and with a moat around it. I think. Yeah. Good question. Am I correct, Peter?
Yes, you are.
Okay. Should I pick one? So.
Well, first I would like a hand for Martijn.
Thanks.
And then I'd be happy to give Andrew the floor for a question.
Niels, Andrew Cormack from Janet. You've skipped very quickly over the helping service providers choose the right LOA. That's very easy. Service providers will always want the highest LOA because they don't bear any of the cost. Have you got a way of balancing that out, that service providers don't immediately demand that IDPs take blood samples from all their users because the service provider, he has a risk and there is no cost in demanding a higher LOA?
Oh, excellent question. Apart from making the fee for service providers dependent on the level of assurance of authentications.
Sorry.
Ken.
A couple of comments. I think I would disagree with my esteemed colleague and think that most service providers would like the lowest LOA to get the biggest possible market. In the science communities, et cetera, we might see that escalation, and that's good. Comment 2 is I saw a recent demo of 5-factor authentication, so you are behind the times. The 5 factors, just for reference, were username, password on the phone, SMS message back to the phone, geolocation of the phone was factor 3, and for the community that was funding this development, they could predict geolocation for some of their employees. Factor 4 was voice recognition app on the phone. And then factor 5 was you turn the phone around backwards, take a picture of yourself, and send it in as photo recognition. So you have some work still to do. The last comment is that there seems to be a tendency now among some governments to reconsider the LOA. And the Canadian government has recently put forward a very interesting document that separates LOA into 2 components, identity proofing and the act of authentication, something we as a community have been arguing for a year. Each one will have a scale from 1 to 4, and that will reinforce how the Google model may be a 2 in active authentication and a 0 in identity proofing, and may help the sales pitch.
Yeah. So about your last comment, I think I think you're right. Maybe we should have something between this very, very flat structure of just one integer and something like this. And a 2-component-based level has, well, we've considered this a couple of times during the sessions with SurfNet. But it's also important to, align yourself with existing standards. And most of the standardization has been on this level of assurance lately.
The actual NIST document that you're referring to is also being recast.
Is it really? Okay.
So it may well embrace this 2-integer approach.
Okay. So dimension 2 level of assurance. Thanks.
Last question.
Enrico Fasanelli. A general question, maybe a little off topic. This morning we saw a Switch colleague that stated that we want to give a single key to the student in order to access anything. Now we are going to the second up to 5-factor authentication. How can we manage this divergence problem?
Right. So, yeah, well, that's a difficult question. So what will Google do? What are they actually doing with their second factor? They're making it as easy as possible for the user when they have some extra information. So if you're logging in from the same computer, they know this, and they will not ask you to present your second factor. So they're doing sort of single sign-on for the second factor. You're only using your first factor if they have some extra information. So they're sort of striking a balance between, they're making it harder for you in certain circumstances, and they're making it easier for you in other circumstances. And they're balancing this. So as a user, if you've enabled, I don't know, do people use a Google account here? I'm sure. So can I see some hands who has enabled second factor authentication? So that's about 1/3. I guess that's not too bad actually. But so if you use this, you'll notice that you don't have to enter your second factor that often if you trust their recognition system of you coming from the same computer and from the same IP address. So maybe that's the answer. I don't know. So multiple factors means that usability goes down, but then you have to bring usability up somewhere else and balance that, I guess. Okay.
Okay. Thank you, Martijn.
Welcome.
Final hand for Martijn. I would like to press upon you the fact that you need to vote for the student posters. You can still subscribe for the open space sessions and something else that I forgot, but it will probably be called tomorrow morning anyway. So. Thank you for being here.